Is clear to everybody? Am I audible? Okay, great. Let me share my screen. Just give me a few seconds. Okay. Can you see my screen? Everybody? Is my screen visible? Yeah, thank you, Saurabh. Is my screen visible to everyone? Can you see my screen? Okay, great. So everyone, please pay attention. So in the last session, we were discussing about the introduction to the embedded system. So in that introduction, we discussed about what is embedded system. Then later we saw the different examples of the embedded system. Even we discussed the different categories of the embedded system, and even we discussed different components of the embedded system. Not all, few of the important components we discuss here. Then next we talk about the requirement of the embedded system, few requirement. Even we discuss what few challenges you may face while designing the embedded system. And even we discuss what are the different trends, what are the different choices you're having when you are doing the development of embedded system. And even we discuss common design matrices of the embedded system. Fine. Now let me start with the new topic, which is talking about the general purpose system versus embedded system. So people, what do you mean by general purpose system? May I know what do you mean by general purpose system? Yes, no? What is this general purpose system? So can I say general purpose system? Yes, very good. Is nothing but the system which is designed for the multiple activities, or you can say it is designed for the general activities or the general tasks. Can I say that as a general purpose system means you can do the multitasking, multiple things you can design, right? Yes, as Nitin is saying correctly. If I talk about the example of the general purpose system, it is nothing but my computer, right? Or laptop, you can say. See people, on the laptop we can do multiple things, a number of things we can do. In fact, use of the general purpose system is depending upon who is using it. Let's say at my home, if I'm using my laptop, you know that on that laptop most of the time I will be doing my office work. Okay, now if my father is using my laptop, so he will go through the YouTube videos of live this one live streaming of the news. Mostly he go through that. And if my brother is using it, then he play games mostly on that. So yeah, thank you, Nandini. So most of the time, what happened? The usage is totally depending upon what who is using the general purpose system, right? Okay, so now see here. Uh, Now on computer you can do the on computer or on general purpose system you can do the multiple tasks. Now, what about my mobile phone? Can't I do the same thing on my mobile phone which I'm doing on my computer? Yes, even playing a game is very easy on mobile phone. Calling is easy. If you ask me, my mobile phone is having right now 8 GB of RAM, and my computer is having just 4 GB of RAM. If you ask me, my phone is what? Octa core, and my computer is dual core. If you ask me, my mobile phone is more powerful than my computer. So what about it? It is embedded system then? Sorry, then mobile phone is also general purpose system. If you ask me, yes, it is a general purpose system, but we are not using that to do the development. So generally, if you talk about the general purpose system, in the general purpose system, main task is what? To do the development. So by using the general purpose system, you can do the designing, you can do the development is the main concern. Now my question is, are you going to use the mobile phone to develop the embedded system, to do the designing of the embedded system possible by using the mobile phone? Can you do the development of embedded system by using mobile phone? You can do it, but are you going to prefer it? Are you going to prefer the mobile phone to do the development of the embedded system? If you ask me, no, because the mobile phone is having such a small screen. How you're going to write the code there? How you're going to have a view of the thousands of line code? Am I right, people? Or you don't have a separate nice keyboard like your computer. Again, keypad will be there. Again, if you're using the keypad, half of the screen is gone. So preference is the question. So are you going to prefer the mobile phone to do the development? Answer is no. So that's why I kept mobile phone under the category of the embedded system. Only reason is we are not preferring the phone to do the development. Otherwise, if you give me the scale from 1 to 10, the mobile phone is around 9.5 general purpose system, but due to that preference, due to that 0.5% of the gap, we are not using to do the development. So that's why I kept it under the embedded system category. Fine. Okay, so let's see what this slide is saying about the general purpose versus embedded system. Okay, so they are asking, what do you think about your desktop or the computer? What type of system it is? It is general purpose or it is embedded system, people? It is a general purpose system. We already took this example. Then on the same slide, they're asking a question. Does the size matter even in the general purpose system or even in the embedded system? Does the size matter? If you ask me, no. So you can have a small system, embedded system like a Bluetooth button or as big as machines which will be used in the industry. Size doesn't matter. Okay, so this is about the general purpose system versus embedded system. Okay, now let me go to the next slide, which is talking about the real-time aspects of the embedded system. Now pay attention. Already in the last class we discussed that what is the real-time system or what is the real-time embedded system. So people, for the given input, if you are able to take the action within the given amount of time, then you can see that it's a real-time embedded system. Okay, then again, this real-time embedded system is divided into the further categories. Let's discuss those categories here. So you can see here, so you can have a hard real-time system, you can have a firm real-time system, or you can have a soft real-time system. Let's try to understand all of this one by one. So what do you mean by a hard real-time system? Hard real-time system means this system has to take the action within the given amount of time. Failure is not encouraged here. This system has to meet its deadline. Usually, if you see the hard real-time system, those systems are deployed in the applications where human life is critical. So usually, hard real-time systems you will see in life critical application. There we cannot afford the we cannot afford the losing a time. We have to meet its deadline. Okay, so examples of this hard real-time system. Can I see the year back? Can I see the year back is the hard real-time system? Yes, no? Yes. So any other example? Can you give me the any other example of this hard real-time system? Yes, braking system. Yes, very nice. See, in short, in case of hard real-time system, if action is not taken on time, what happened? We are going to lose the human life. Try to understand. So this is what hard real-time system. Then let me come to the soft real-time system. So what do you mean by soft real-time system? So in the oh, is it? I'm not audible. Somebody saying no voice, no video. Pacemaker is also very good example. Ventilator is also excellent example. Very nice. Yes. Autopilot braking is also very nice example. Oh yeah, correct. Fine. Yeah, all is well. Yeah, thanks, Nia. Now let me go to the soft real-time system. So in case of soft real-time system, what happened, people? We can have a tolerance in the meeting deadline. That's fine. It's okay if there is a delay in meeting a deadline in case of soft real-time system is acceptable. Okay, so I'm talking right now about the soft real-time system. Okay, in case of soft real-time system, you can have some tolerance, you can have some delay in meeting a deadline. If the action is delayed, nobody is going to die. These are not in the life critical application, so that's fine. So let me give you the example. Okay, people, so if you ask me currently, right now, if I'm not wrong, India versus Nepal, World Cup final is going on, Asia Cup, if I'm not wrong. Am I right? Yes, no? Am I correct? Whatever I'm saying, is this right? I hope you're following cricket. Oh, I'm so sorry. I did the mistake here. I hope you're following the cricket. Asia Cup is going on, right? No, currently, if I'm not wrong, okay, it's a final, or whatever it is. Let's say this Asia Cup final match is going on, and let's say you're watching this broadcasting on your TV. You have a smart TV at your home, you are watching it. Now, people, whatever going on the ground and whatever you are able to see on the TV, if there is a delay of 2 minutes, it is acceptable. That tolerance can we accept? No. Or let's say, or okay, let me say it this way. Uh, how can I create a scenario? Chalo, not Nepal. Let me go with the India versus Pakistan match. Okay. Let's say it is a very old match. Let's say your watch, unfortunately, due to some reason, now try to understand here. Due to some reason, you're watching this match on your TV, you're not in the stadium. So let's say you're watching it on the TV. Let's say India is playing the second inning. First inning played by the Park. Let's say around 80 runs scored. Okay, fine, 80 runs scored. Okay, let's say it's a 2020 match. Now India is playing. Okay, now let's say on the crease, let's say I'm taking the old scenario. Let's say on the screen right now, MS Dhoni is playing. Okay, and current score of the India, let's assume, let's say it's a 175. How much is the score? 175, and it's a 2020 match, and let's say around 19.5 overs are done. Okay, so who is playing currently? Who is on the crease? Let's say MS Dhoni is there. So how many balls are there currently? How many balls India is having? 19.5 overs are done. How many balls are there? Just one ball. Am I right? Okay. So now what is our expectation from MS Dhoni? As an Indian, what are we expecting from the MS Dhoni? We are expecting, come on, boundaries enough? Come on, to clear the match, to how many runs we need? Don't you think we need to score 181? So no, so we want 6, right? Oh yeah. So which shot are we expecting from the MS Dhoni? Do you remember the famous name of that shot? Yes, helicopter shot it is. Right. Nice. Fine. So no, I'm just taking the scenario. Many people are fan of MS Dhoni. That's why I'm taking the scenario. Fine. So what happens? So we are expecting a 6. Okay, now see the scenario. Now, let's say, Afridi is doing a bowling. Let's assume from the Pakistan, and let's say he did the bowling action. Pay attention, you're watching this match on the screen. Afridi is doing the bowling. He did the bowling action, you're watching it on the TV, and your TV signal got scrambled, let's say for a minute. What will happen? Your TV signal got scrambled. Oh, come on. Are you going to throw the remote? Yeah, you will be angry. But are you going to die because of that? Let's say for the minute, 2 minute, your TV signal got scrambled, nothing is visible. Anybody is going to die because of that? Obviously no. Obviously no, right? So this tolerance we can have. That's what my point in the point in the previous example also. So what happened in this case? This tolerance we can have a delay in meeting the deadline. So what is the expectation? Yeah, obviously for all of us we wanted to see that last ball, how it is gone. So if it is 6, what happened? N number of TV channels, N number of news channels are there. They will show this is what the finishing shot of MS Dhoni. This is what the 6 of Dhoni. This is Dhoni ne aisa 6 mara, Dhoni ne waisa 6 mara. That type, that shot you can see later n number of times, right? So because of the delay, nobody is going to die. So this is what soft real-time system. But in case of hard real-time system, opposite of this, let's say you have a hard real-time system. Let's say, let me take the example of the pacemaker. Okay, so are you aware with the pacemaker? Are you aware with it? Pacemaker, what it is doing? It is helping to pump the heart, right? Now let's assume pacemaker is not taking the action for the 2 minute. What happened? Let's say you have a hard real-time system pacemaker. In that, you cannot have a tolerance in the meeting the deadline. It should meet the deadline. It should work properly. It will be used. Hard real-time system will be there in the life critical application. So don't you think literally pacemaker is not working for the 2 minutes? What happened? Heart is not pumping for the 2 minutes. Then what happened? Disaster may happen, right? That person may have to lose their life. Am I right? Don't you see here directly? It causes to the human life. So understood the difference between hard and soft real-time system. Okay, few of you not aware with it. At least let me take the another example. Few of you don't know what is the pacemaker. No problem. Okay, can I take the example of the airbag system? What say, guys? Can I take the example of airbag system? Those who are saying okay, airbag system. At least you know how the airbag system is working. Now let's say, unfortunately, somebody met with the accident. So after the accident, let's say it's a very, very, very disaster accident. So what is the expectation? Don't you think that airbag system has to come out immediately? It has to take the action immediately. Now let's say the airbags itself not coming out literally for the 2 minutes. What happened? Is there any use of airbag to save the human life in this case if it's not taking the action? No use. You understood my point. What do you mean by life critical application? Yes, hard real-time systems are usually deployed where human life is critical. You can see the life critical applications in case of hard real-time system. And in case of soft real-time system, that's fine if you have a little tolerance in the meeting deadline, fine. Okay, now let me talk about the firm real-time system. So people, this firm real-time system is similar to the hard real-time system. But here, if there is a failure in case of firm real-time system, you're going to lose the money. You're going to have a loss in terms of money or in terms of property. So let's say you are designing a system, it has to meet the deadline as per the hard real-time system. But what happen if it is failed? You're going to lose the property, not the human life. This is the basic difference between the firm and hard real-time system. Yes, fine, you can say the stock market, no problem. Oh, fine, understood. Or let me take the example here. Let me see the example of the moon rover. Okay, now let's say moon rover is there. Yeah, let's take the example of the Chandrayaan 2. Fine, good example, Sarfraj. Chandrayaan 2 name of the moon rover, which was the mission previous to the Chandrayaan 3. Now see here. So what happened when a rover is shooting towards the moon? Two possibilities are there. When it is reaching on the moon, what are the two possibilities of the landing? May I know what are the two possibilities? Either there will be the safe, successful landing, or there will be the crash landing. Am I right? Either there will be the safe landing or there will be the crash landing. Okay. So people, if it is safe landing, soft landing, safe landing, or successful landing, no issues, no problem. No problem. Everything is fine. So are you going to lose the property? No, because it's a success, correct? But if there is a crash landing, that means if there is a failure, what happened? Don't you think if there is a crash landing, you're going to lose the property here? Just you will be having the loss in terms of property, whatever time you invested, whatever money you invested to design that system, it we are going to lose that millions of dollars we are going to lose if it is a crash landing, right? So here firm real-time system is related to the property loss if the action is not taken within the given amount of time. Understanding? Okay, so to just make it little clear difference, or let me to make it little clear, let me take the example this way between the firm and hard real-time system. Let's say there is a moon rover. Let's say a moon rover is there, but this time we are sending the human, okay, in that rover. What we are doing, we are sending the human is also going on the moon in that rover. Now in that case, if it is a crash landing, don't you think human life is getting affected in that case? Don't you think if human is going in the rover, then what type of system it is? It become the hard real-time system. Understood? Very good question. So it become the hard real-time system. Otherwise, if just to property loss, it is a firm real-time system. So this is about the different real-time systems: hard, firm, and soft real-time system. Understood? Everybody? Clear? Okay. So finally, we completed the introduction to the embedded system. So we are done. Fine. Now let me come back to the slides where we started. So here we completed the introduction to the embedded system. Now let me go ahead with the introduction to the microcontrollers. So people pay attention here. So let me directly start with the what is microcontroller. So guys, can you please answer me what is microcontroller? At least all of you studied the microcontroller 8051. So may I know, according to you, what is microcontroller? Everybody, please try to answer. Even if it's not an exact correct technical answer, that's fine. I'm not expecting typical technical answers from any of you. What you understand from the microcontroller, I just want that. May I know what is microcontroller according to you? Examples I don't want. In general, I'm asking what is the microcontroller? Nice answers. I can't read everybody's responses, but I'm checking it. Okay, so few people are saying it has inbuilt elements, inbuilt memory. It is IC given to embedded system. It's a general computer. Okay, if you are saying memory plus input output ports plus processor, fine. Nice. See how nicely you all are answering. Very nice responses. Yeah, very good, guys. Okay, chalo. I'm still waiting for your answers. Go on. Okay, very good. Fine. Accepted. Whatever answers you are giving, I accepted that. Now let me show you what we are mentioning here in our slide. So what this slide is saying, what is a microcontroller? They are saying, okay, or before going into what is microcontroller, so let me answer whatever answers you given, those are absolutely right. Or let me talk what is microcontroller. As you are saying correctly, it is an integrated circuit which is capable of being programmed to perform a specific task. Okay, so what happened? Microcontroller is nothing but the IC that we can program to design the embedded system to do a specific task. Okay, now question arises, guys, everybody, why we are using the microcontroller, why the topic is introduction to the microcontroller. Can't I do the development? Can't I design the embedded system by using computer? Can't I design the embedded system by using SoC? Can't I design the embedded system by using the microprocessor? Why microcontroller? So people, here our aim, our everybody's aim is what? To design the embedded system which will be lightweighted. Okay, that will be not much complex. If you are designing the lightweighted system, then what happen in that case? Okay, what happen, we don't have much complexity. If tasks are not much complex, then what you can do, you can do the development, you can do the designing by using the microcontroller. If it is complex, then you may need a OS in it, you may need a SoC. But here we are developing the simple embedded system like microwave oven that we can design by using the microcontroller. That's why we are studying the topic microcontroller. Okay, and what is a microcontroller? It's an IC which we can program to perform a specific task. But people, if you are going with the microcontroller, you may have some restrictions. What are those? First restriction is nothing but the memory size. What does that mean? That means people, micro, as you said, or many of you said correctly, microcontroller comes with the built-in memory. So whatever programs we are writing, we have to write in a such a way that it will fit into the available memory. Otherwise what happen, if needed we can't upgrade this memory. So whatever memory size we are having, we have to fit our code in that restricted memory only. Like our computer, if needed we can upgrade the RAM, right? But here we can't, it's not expandable, right Sonali? Then IO capabilities. So what happened? IO capabilities, in case of IO capability means input output capability. So basically for the different microcontrollers, it's IO capabilities totally depending upon how many lines it is having. So if you have a few microcontrollers are 40 pins, few microcontrollers are 20 pins, and based on the number of lines, IO capabilities will vary. Okay, and even it has a built-in peripherals. Those are also a kind of restriction. Means if you have only one timer, you can't add another one. You have to go with that. So like that way, few peripheral function restrictions also we are having if we are doing the designing by using the microcontroller. Fine. Okay. So this is about the what is microcontroller. Fine. Now let me go to the next slide. Okay. Your favorite question from the last class, I will be getting this question. Ma'am, what is the difference between microcontroller and microprocessor? Many of you asked. The plan was to cover that thing in the today's session. Now focus here. Many of you already asked this question. What is the difference between microcontroller and microprocessor? Let me talk about the microprocessor first. Okay. So in case of microprocessor, people, do we have a built-in components? I mean, memory, IO ports, timer, all these components are built in into the single chip of microprocessor? No. So all components are the separate components. As yeah, you can see the picture here. So whatever memory, timers, port, CPU, everything is separated. So what is the advantage of this? Okay, these components are separate. It has advantage. What? More flexibility. I mean, if I need, I can upgrade the memory. If I want, I need another timer, I can add that timer. You have a more flexibility in case of microprocessor. But don't you think everything is separate? There will be the more design complexity, right? You have to design things, you have to collect all the chips, all the components together. So it will increase the design complexity. Understanding? Okay. So can I get the one example of the microprocessor, people, which you used? Can I get the one example? You might be studied or you might be studying this microprocessor 8086. Okay, you might be studying the ARM, okay, other also, but usually I can see in many universities this 8086 is there. Fine. So okay, so this is about the microprocessor. Now let me talk about the microcontroller now. So what about the microcontroller? So if you see the microcontroller, what about the components, whatever memories, whatever timers, whatever ports, whatever other peripherals are there, those are going to be separate like a microprocessor in case of microcontroller? No, big no. So all components are integrated together, built into the chip. You can see all components in the single chip. So within a single chip, you can see your timer is there, ports are there, memory is there, CPU. Everything is together, kind of built into the single chip. So what is the advantage of this? Advantage is less design complexity. You don't have to integrate all these components together. Those are already built in. So due to that, there is a less design complexity, but it has one drawback also. What it is? Less flexibility. Am I right? If I want to upgrade the memory, can I upgrade? No. If I want to add the timers or other peripherals, can I add? No. Less flexibility is there. So this is the basic difference between the microcontroller and microprocessor. At least you should know this much basic difference. And if you ask me the example, as you are all aware with it, 8051 is the very basic microcontrollers. I think all of you studied. Am I right? A lot of other are there. In general example I'm taking so that everybody might be studied that. So this is what basic difference between the microcontroller and microprocessor. You can say that, Mahavish, if a system doesn't require, those might be wasted. You can see that. Fine. So at least you should know this much basic difference between the microcontroller and microprocessor. I don't remember the name, but many of you are asking in the last session, ma'am, what is the difference between microcontroller and microprocessor? I hope you got the clarity. Everybody? Yes, no? Okay, now let me go to the next slide. Okay, next slide is talking about choosing a microcontroller. Okay, now choosing a microcontroller. Let's say tomorrow you're going into the market to choose a microcontroller for your embedded system. So then how are we going to choose? What points we have to take into the picture? What points we need to take into the picture? So these are the different points. So people, while choosing a microcontroller, while selecting a microcontroller, you please select based upon the applications. Means, let's say you're working on which application, you know what is your application, what is your need. So for example, your application is saying that you need a ADC. Okay, application means the product which you are designing, embedded system which you are designing. That since I'm saying application, let's say to develop the embedded system, to develop your application, let's say you need a ADC. Okay, then choose a microcontroller which has a built-in ADC depending upon what you need. Okay, then performance. What kind of performance you want? Are you looking for the performance piece-wise or the time-wise? So select the microcontroller which support that. Then price. So don't forget the price. People, see here. If you are going to purchase a microcontroller ICs in the bulk quantities, then it will be cost effective, otherwise it will be costly. So if your microcontroller cost itself is going to be more, your end product, end embedded system is cost is going to be high. And as we studied already in the previous slides, please make sure your product is affordable. So take care of the price also. The next very important point is availability. So what do you mean by availability? So people make sure for whatever period you are designing your embedded system, that period your chip is available. Whatever microcontroller you selected, make sure it is available for that particular time. Let's see here. You are designing one embedded system, one application. You did the designing and you started production. So you selected a one microcontroller, okay, and people, you will be doing the production, let's say developing the embedded system, doing the production, let's say for the next 2 years. Okay, now you selected the microcontroller. So people, in every microcontroller, whoever is the manufacturer, please go to that website of that manufacturer and check their EOF, okay, EOL, end of life. So every chip's end of life they mention. So when the production of that particular IC, that particular chip is going to end, it is mentioned. Now let's say you selected the microcontroller, and this microcontroller life is going to end just after 1 year. Okay, whatever IC, whatever microcontroller you selected, its production is going to stop immediately after the 1 year. But guys, don't you think you need that microcontroller at least for the 2 years, right? But if the production of the microcontroller is stopped within the next year, then are you really going to do the designing again by selecting another microcontroller? Do you? Answer is no. So what you have to check? You have to check the availability first. For how much time the chip is available, what is the end of life. So whatever period you want, for that particular period, that microcontroller is available, then choose that one. Understood? Yes. Two ICs is fine, but both the ICs life is going to end after the particular period, then what? Suprit Kumar, then what? Again chaos. So better to check the end of life properly when that chip is going to end. Understood? So in simple term, you have to check whether the microcontroller is going to available during your entire production. Check that. If it is available, choose that. Otherwise, go with the another one. Understood? Again. Next point is availability of the tool. What does that means? You are selecting a microcontroller, but do you have all the tools to develop that microcontroller? If you have, go with that. Otherwise, you selected the microcontroller, but you don't have a tools to work on it. No use of it. So please take care of this point also. And then spatial capabilities. So few manufacturer provide the spatial capabilities of the microcontroller to attract the customers. If you need those capabilities, select that microcontroller. Spatial capabilities means what? For example, as I said earlier, few microcontrollers comes with the built-in ADCs. If you want the ADC in your application, select that microcontroller. Even few microcontroller nowadays coming with the Ethernet also. If you want that, please go with that microcontroller. So basically, what you have to do, you have to choose a microcontroller by considering this one. So this is what the procedure to choose the microcontroller. Understood? Fine. That app memory point will be covered here. For your application, if you need a more memory, then the which microcontroller is having that memory, select that one within. Yes, lot of other special capability, lot of other features are also there, which I'm not covering all. Just I'm taking example. Understanding? Fine. At least making sense whatever I'm saying. Guys, are you able to follow me? Okay, so this is about the introduction to the microcontroller. Now, finally, availability means for how much time the product is available, for how much duration. Let's say you selected a PIC microcontroller. So usually PIC microcontrollers are manufactured by whom? Microchip, right? So how much duration microchip is going to manufacture that microcontroller? You have to check that. So if it is available for your expected duration, pick that. Understood? Availability of tools means what? Now see here. So we are going to do the programming of the microcontroller by using which tools? If you ask me, we are using all the software tools. Means for example, here we will be using what to write the codes. We are using what? MPLAB, XID. Am I right? Then to see the output, what we are using the Pixim Lab, right? So like this way, whatever development tools you need, those are available, and microcontroller is supporting those, then choose that one. Understood? I didn't show one. I'm just taking one example of the pick microcontroller. You can take any microcontroller, no problem, based on your need. Understood? Tools means move on, clear, so on. Chalo. Now, fine. So now, finally, let's go ahead with the programming part. Everybody, pay attention here. Okay, so finally, let's start the embedded programming. Okay, so everybody is listening. Lot of theory we covered. I know. I hope nobody is sleeping. Can I get the response here? You guys are there? You guys are listening? Chalo, we are done with the theory part that we need to understand. Anybody is sleeping? I hope you all are attentive. I hope you all are listening. I hope I'm not making this session boring. I hope so. This was the theory. At least you should know the knowledge of these things. Okay, chalo then. 2 minute break you want? Okay, no problem. Take a break of 5 minutes. A Emertxe is our company name. Emertxe Information Technology. These slides are by my company Emertxe. Okay, fine, no problem. Take a break of 5 minutes since few people are requesting. So around 7:50 we will continue. Fine, take a break. You will also take a break. I will be also taking a break. Fine. Have a water and let me know. Yes, these slides are available in the LMS. Fine. Last few minutes I will keep for your queries. Okay. Yeah, sure, Navin. I will try. I'm taking examples, simple examples, so that everybody can understand. That is the only concern. Fine. Thank you, Vedashri. Thank you so much. Yeah, but guys, take a break and we will continue by 7:50. Be there. Yeah, it's a 7:50. Everybody is there. I informed to open the test results. Fine. Prakul, I didn't open my linked list from the longer duration. So, anyways, no need of this. We are going to officially provide you the certificates. Anyways, I will check my linked list for okay. Check my LinkedIn. Fine. Okay. So, can we continue? Everybody is there. Mm-hmm. Just respond yes in the chat box. And test results I already informed to open. Those will be open soon. Don't worry about the exam. You wrote the exam, na? Fine. My name is Rajni. I already mentioned many times. Okay, fine. Others are there. Okay. State and all leave that. We all are in Emertxe right now. We are a team Emertxe. Fine. Okay. Okay, chalo, continue. These things we will discuss at then. Let's focus on the main part of the course. Now we are finally starting with the microcontroller programming. So when you are jumping in this programming, at least you should know few important terms. What are those terms? First term means your host. Host means the system which you are going to develop, that target the system to do the development, the system which we are going to use. Now people, in simple terms, so you are developing the microcontroller, or you will be developing the pixim board by doing the coding. So what you are going to use to write the program to do the development? What are you going to use? Obviously your laptop or your computer, right? So what will be your host system? So your laptop, your computer is going to be your host system. Okay. The next term is nothing but the target. So what do you mean by target? Target means the system which is being developed for the specific application is nothing but the target. So whatever microcontroller or pixim board which you are going to develop, it is nothing but your target board. And then cross compiler. So first of all, may I know people, what do you mean by compiler? Guys, what do you mean by compiler? In general, can you talk about the compiler? Everybody? What is compiler? Mm-hmm. Am I asking difficult question? I'm expecting the core use of the core meaning of the compiler. See, I'm getting the few good responses, but I'm not expecting the few other responses also. See here, usually what happened, we are writing the programs in some higher level language like C, Java, right? In higher level language we wrote the program. So your system, your computer understand that language? Does your computer understand that language? No. So computer understand the language of zeros and one binary, right? Machine level language. So what happened? Whatever code is written in the higher level language, it has to convert into the machine level language. So who is doing that conversion? Compiler. Understood? As you many of you said correctly, compiler is nothing but used to convert high level language code to the computer language or the machine level language code. Understood? Yes, kind of interpreter. Okay, fine. Chalo. Then here I'm talking about the cross compiler. Fine. So what do you mean by cross compiler? So today we are talking about the process in which code we will be writing in our PC. Okay. Even that code we are going to compile in our PC itself, in our laptop itself. But that code we are running where? In the microcontroller, or you can say in the another architecture. So where that code will be running? Inside your microcontroller. So this is nothing but the cross compilation process, so in which code is written in your laptop, in your PC, even it will be compiled in the PC itself, but where it is running in the microcontroller. So your PC is having different architecture and your microcontroller is having different architecture. So what do you mean by cross compilation? Cross compilation is nothing but the process which is used to generate a code for a different architecture being in a different architecture. Means, for example, PC is generating the code for the microcontroller. That is nothing but the cross compiler or the cross compilation process. So if you ask me which cross compiler we are using, X8. So already all of you did the installation of the X8 compiler, yes or no? You already, that's why here we will be using the cross compiler, and all of you already completed the installation of it. Fine. Okay, then next slide. Okay, chalo then let's start with the coding. Thank you, Naveen. Let's start with the coding finally. Now see this program, everybody. See this code. So are you able to understand this code? This simple code. Are you able to understand, people? For what this code is used now, people, may I know what is the aim of this program? Why this program is written? Can you tell me? Don't you think this program is very simple for what it is written? Or let me write it here. See here. See here. What is your program? That is a header file hash include stdio.h. Fine. Then let's see integer mean. Okay. There will be written 0, and here I'm having integer x. Okay, let me just cross check. Fine, here it's I'm assigning the x with the 20, and here I'm calling a printf, and I'm just doing percentage d new line, and I will be passing the variable x. Okay, so what is the aim of this code? As you all of you are saying very correctly, I'm writing this code for what? I'm writing the code to print the value of the x. For what this program is written? To print the value of x, and this is nothing but the 20 in this case, right? Now question is, right now we are started with the embedded programming. Okay guys, so where are we trying to run this code? So don't you think obviously in our target board, whatever is the target board, we are planning to run the code in the target board. So people, then you should know the knowledge about the few things. Okay, so since you are going to run this program in your target board, so now question is, does it have a OS in it? Does it have a OS in it? So the answer of this question is depending upon this slide. Yes, you are running in your embedded system, but that embedded system support OS. Are you integrating the OS in that? So answer is depending upon the few of these few points. First is complexity of your work. Are you working on the very complex task like a router or mobile phone? If you are doing like that, yes, you need OS, but here complexity is simple. So if you are working on the complex application, or if your project itself is saying you need a OS, then you have to include it. But what is our aim? What is the scope of this model? So in this model, what we wanted to do, we wanted to learn the low level microcontroller programming, and that will be non-OS based. So do we have a operating OS? Means operating system. So do we have OS in it? Answer is no. So what type of approach we are using? Bare metal programming we are doing. What do you mean by bare metal programming? which is the programming which is non-OS based, that is bare metal programming. Since we are doing the simple task, which is don't need a OS. So this is bare metal programming. Okay. So if there is no OS, then approach will change little bit. How it will change? If you see here, no need to do return here. Okay. Not necessary. So you can have a void here. Even then you can update this. You will not be having any command line argument. Code is updated, but still I updated the code since I'm not having a OS in it. But what about the aim? Is the aim changed? Is the aim changed? Don't you think I'm still doing the same task? Still my aim is to print the value of X. Am I right? Now I have a next question. Yes, you will be running this program in your embedded target, in simple term, in your embedded system. Now question arises. Does your embedded system support this type of coding? Or if you are trying to print the value of X, is your target having a screen to print that value? Is your target having a screen? Does it support this type of coding? Too many questions, yes or no? So people, so don't you think before doing the programming, at least you should know the architecture of your target? Don't you think? At least you should know the architecture of your target board? Yes, no? So let's try to get the idea about at least the architecture before proceeding with the programming. That would be better. So whatever question just now I asked, does it have a screen? Does it support the print statement? All these questions are depending upon your target board and development environment. So let's try to get the answer of this question just by going through the architecture of your target board. So people, what do you mean by architecture? Okay, what do you mean by architecture actually? In general, if you see, the architecture means overview of your board, right? So what is there in the board? What are the peripherals? What are the peripheral interface? Just overview about the your board and its peripheral. So people, which board we are using in this case? You remember what I said? So we will be using PixSimLab simulator board. So let me show you the architecture of that board. Pay attention here. So this is what the architecture of the board. So pay attention here. So heart of this board is nothing but this microcontroller. So to do the programming, which microcontroller we will be using? We will be using PIC 16F877A. Okay. So now we are going with PIC microcontroller, PIC 16F877A. This is the heart of that particular board. Okay, then what you will be having on your board? RS232 port is there, LEDs are there, buzzer is there, digital keypad is there, 7-segment displays are there, matrix keypad is there, CLCD is there, EDC also we are having, temperature sensor, LM35 is there, I2C, RTC, double EEPROM, external double EEPROM, RTC chip is also there, and other GPIs are there. So people, I'm so sorry. If you see all the components of your board, what do you think to do the programming or to start with the coding, as you all are doing the programming from embedded programming from the scratch? So what do you think, which will be the easiest component to start the embedded coding among all these? What do you think? Other, what is your opinion? I will answer, Bhargava, I will answer your question in upcoming sessions. Okay. So, which is the most easiest peripheral? Yes, I will go with the LED. So even buzzer is very simple, but it having very irritating noise. So I will not use the buzzer first. I will go with the LEDs. Fine. So let's pick the LED and let's do the programming. Fine. So what we are going to do? We are going to do the programming of the LED for what? To uh, for what? To the to learn the coding first. Okay. So people. So what we are doing? So my question is, among these components, if you see the board architecture, so you are having the different components like LEDs, buzzer, digital keypad like this. So which one is the easiest one? As you said, many of you said correctly, LED is the simple component. So let's go ahead with the programming of the LED. Okay, now everybody pay attention. So today we are starting with the LED programming. Okay, now let me update the code. Fine. So now let's have some assumptions here. I will be clearing these things, but to start with, let's have some assumptions here. Now to turn on the LED, okay, let's say to turn on the LED, you have to put the 1, okay, and to turn off the LED, okay, or to keep it off, what you have to write? You have to provide the signal 0. You have to give the 0. Let's have this assumption. Okay. Now let me copy this code. I'm copying it. Pay attention, everybody. Now let me change this code. Fine. Now see here. I'm doing here this integer, let's say LED. Let me turn on it. Fine. So let me turn on the LED. So what I will be doing? So I wanted to what? I wanted to turn on the LED. Fine. So as per the assumption, so this assumption I'm saying that to turn on the LED you have to put the 1. So I'm writing LED equal to 1. So what happened, people? What happened? This program is going to turn on my LED. I changed Prakul this integer with the void because we are doing the non-OS based programming. So in that non-OS based programming, it's not necessary to return the integer. Void you can have, no problem. Okay, fine. Okay, let me come back to my question. So what happened, people? Will this program turn on the LED? Whatever LED I'm having on board. So you can say this is the board. So here you can having many LEDs. Let's say LED 1 I'm turning on. So what happened? Will it turn on the LED 1? Will it turn on? I didn't under. Oh, this one. Okay, inside the bracket. See, others, you answer my another question. So if it is non-OL based, generally, if you want to accept the command line arguments, where you accept here, right? So I will not be accepting any command line argument. That's why I kept it void. So otherwise, you leave it, no problem. If you are getting confused, fine. Fine. Now let's focus on the main question, Prakul. See here. So what happened? Is this program going to turn on my LED? Few of you are saying yes, but many of you are saying no. May I know what will be the reason? May I know what will be the reason? No is the correct answer. I accept that. But what will be the reason? I'm asking the reason. Very good. Mm-hmm. Very good. Nice, nice. Chalo. Accepted. You have a good understanding. You are getting my point. Nice, nice. Very nice responses. I'm very happy with the responses. Now see, if you see the simple program, literally whatever you are able to see, answer. What is this LED, people? If you see this simple program, what is this LED? If you see this program, what is this LED? Variable. What type of variable? Don't you think it is just an integer variable I declared? So this LED variable means the LED of this, whatever onboard LED we are having, it is this LED? Obviously no. It is what? Just a simple integer variable, right? Now people, LED is the peripheral. Okay. So usually how the see here, on this board. So this is your microcontroller, and here are the LEDs. So usually how the external peripherals are connected to the microcontroller, by using what? By using which pin? By using what? Many of you already answered that. How the any external peripherals are connected to the internal pins of the microcontroller? By using ports. Very good answer. By using the port pins. Nice, nice, very good. See here. If anybody is not able to understand, let's try to understand here. Yeah, you can see this is my microcontroller. By the way, which microcontroller we are using? What is the name of our microcontroller which we are doing the programming here? We are using the PIC16F877A, right? Sinchna, why you are saying 8051? Here, what we are using, you might study 8051. Come on, don't answer like that, anybody. So which microcontroller we are using? Remember the name. You know what happened? People will complete the project, or people will literally finish this module, and in their interview, if interviewer is asking, you work on which microcontroller, they are not even able to answer. How bad it is. Don't see the pick in the pick. Lots of microcontrollers are there. So out of that, which one you are using? Remember the series name. Pick 16F877A. Note down if you want. Okay. Now you may have a question, why I'm going with this PIC16F877A, why not with the 8051? So if you ask me, people, 8051 is very basic microcontroller. It's not as strong, it doesn't have many features, so we are not using that basic one. But again, why this particular PIC microcontroller? Okay, so if you open this PIC lab board, it has a list of microcontroller which it supports. So among this list, this board works perfectly fine with the PIC16F877A. That's why I selected this particular microcontroller. Somebody was asking, this is the reason. Fine. Okay, so let me go back here. So this is your microcontroller, and we are talking about the LED. So do you know the symbol of LED? LED is nothing but the peripheral on board, external component on board. Okay, so what is this? What is this? Is this LED? What it is? Whatever I drawn on board, what it is? It's a diode. Am I right? So what happened? What is the difference between the LED and the diode? So when current is flowing through the LED, what it does, it emits the light. So if I'm showing this arrows, what it become? It become LED. Am I right? And where the LEDs are, where LED is connected? One of the port pin of the microcontroller, right? Fine, nice. Fine. So usually people, these ports are acting like entry for the outside peripheral, not only LED. So whatever external peripherals are there, those peripherals are connected to the microcontroller by using what? By using the ports. Okay. So port is the interface between the microcontroller and between the external peripheral. Okay. Fine, by using the ports, connection is happening. Okay, no problem. Now, people, for a moment, forget about the LED. Just for a moment, forget about the LED. Do you know this microcontroller PIC16F877A? Okay, PIC16F877A. So this microcontroller is having how many ports? Do you have any idea about that? We will talk about the LED, but to make sure to which port LED is connected, at least you should have understanding about how many ports your microcontroller is having. Okay, few of you are saying 40, few of you are saying 16. Fine. Let me tell you one thing. So this microcontroller PIC16F877 is having total 40 pins. It's a 40 pin device. Fine. Answer. Now I'm waiting for your answers. I got the answer as a 40 port, 16 port, 6 port, port A, B, C, D. That means 4 ports, 5 ports. Okay, fine. Okay, I accepted. I'm accepting everybody's answer. Okay, but just I have one cross question. Based on what you are giving this answer? Based on what you are giving this answer? May I know, guys? Based on what you are giving this answer? Based on just, okay, so you are now, see here. Are you answering just by looking at this number, series number? Just because 16 is mentioned here, that means 16 ports are there? That's what your assumption, or that's what your answer? Or it's a PIC microcontroller, so it might be having 8 ports, 13 ports, based on how you are answering. People. So guys, always based on 8051. No, Baba, 8051 is different microcontroller. What is the relationship of other microcontroller with this one? So, suggestion to everybody, never answer technical questions like this. No, never answer by looking at the Pixim lab also. How Pixim lab will talk about the internals of microcontroller? No, you can have a schematic of its own in the Pixim lab, but not the microcontroller. So, to answer this question, which document you have to refer, which technical document you all of you need to refer? You're simply looking at the series, just number, just simply looking at the Pixim lab, you can't answer. So what you have to refer? Very good. You have to refer the data sheet of the microcontroller already in the material which is provided to you. Data sheet is provided. Open that data sheet. You can see here. Might be multiple data sheets are there. Open correct data sheet. Pick 16F877X. Here I'm opening a data sheet. Pay attention, everybody. Now, if you see this document of data sheet, how many pages it is having? No, Nitin, it's totally wrong. Whatever assumption you are having, that's absolutely wrong. So you have to give at least this technical answer by referring the technical document, which is datasheet. Use all in general for any microcontroller. Always use this approach. Okay. Never predict. Never assume the things. Everyone. Chalo. Now see this document. I open here. So this is the data sheet of your microcontroller PIC16F877XA series. So I will be referring this for 877A. So how many pages this my data sheet is having, everybody? Mm-hmm. Yeah, I'm sorry. How many pages? 234 pages. So see people, it's a technical document. Literally technical things, technical doc is there. So, if you are going to start reading this document from the starting, it will be very boring if you ask me, and it's not feasible also. So, I have one suggestion. Whenever you are going to start referring this data sheet, remember for what purpose you are referring the data sheet. Just only read that part, implement it. Again, if you need to refer the data sheet, open it, refer it for the requirement, and implement it. It's not feasible to start reading from the page number 1. It's not a novel, it's a technical document. Okay. So here, why we came to this data sheet? May I know why we came to this datasheet? To check how many ports microcontroller is having, right? Already this datasheet is uploaded in the LMS. Okay, so we have to check how many ports this microcontroller is having. So either for that case, you can refer the table of content. But if you're not able to see the required part in the table of content, it's a PDF document. You directly search for it. Let me press the Control F. You can see search window is appearing here. Okay. Now let me go to the block diagram here. Okay. So let me search for the block diagram. Fine. Okay, lot of searches I'm getting. Just use search if you're not able to get it. Okay, I got the block diagram. So people, this is the block diagram of my microcontroller or our microcontroller which we are using. It is a block diagram. Can I refer it for the PIC16F877A? No. It is for what? PIC16F873A and 76A, not ours. Let me go here. This one. Can I refer to this one? What say? It is for the PIC 16F877A. Yes, it is. Fine. Now take a 5 minute, everybody. Or if you have all the resources downloaded in your system, you would have open this datasheet in your computer or the laptop and let me know. Just go through this and let me know how many ports this microcontroller is having. Go through it and let me know, everyone. Be in hurry. Go through the things carefully and let me answer whatever my question is. My question is, I'm just interested is how many ports my microcontroller is having. There is a difference between the pin and the port. Okay, so it is having the 40 pins, but how many ports are there? Very nice, very nice. How many ports you are able to see from this block diagram? Nice, very good. So you can see the 5 ports. Very good, people. Okay, so can you give me the names of the ports also? Can you please mention the name of the ports also, people? Mm-hmm. You use the proper name. Huh? Don't simply give the small ABCD, capital ABCD, not acceptable. Use the proper naming. Have a habit to use the proper name. Otherwise, things are not going to work. Nothing is there like just ABCD. No. Use the proper name, use the proper capital letters, have a habit of it. So, what is the names? Name is nothing but there is a port A, right? Then there is a port B. I'm forcing you to go with the proper names. There is a port C, there is a port D, and there is a port E. These are the names. So you might be studied the other ports names in case of other microcontroller like D0, D1, D2. That's fine. But for this microcontroller, how many ports are there? 5. And what are the names? Port A, port B, port C, port D, and port E. Very good, everybody. Now, even just by looking at this block diagram, can we even talk about this? Can we talk about the direction of the port? I mean, whatever data of all this port is accepting, it will be bidirectional or it will be unidirectional. What do you think? See the arrows are talking about the direction. So don't you think every port is having the arrows towards the both directions? So that means it's a both side. You can send the data, receive the data in simple term. So it will be bidirectional. Nice, nice. So you have a 5 ports and it will be bidirectional. Am I right, everybody? Very good, very good. Fine. Nice. Even can we talk about the size? Hush, keep the things simple for everybody. Whatever you are able to see here, that only part is included. Okay. Now let me talk about the port E size. Can just by looking at this block diagram, can you even talk about the size of the port E? Everybody? Mm-hmm. Nothing is there like a RA. I'm sorry if you are saying RA, RB, your answer is wrong. So do we have anything with the name RA? No. Be proper while answering. Have a habit to answer things properly. Mm-hmm. Okay. Okay. Go through it, everybody. Again, go through this diagram. Once again, look at this port. Don't be in hurry. So how many pins are you able to see here? That will be the size. How many pins are you able to see? Uh-huh. Ayo. 6 pins. 1, 2, 3, 4, 5, 6, not 7. Don't be in hurry to answer the question. Even if you are answering with little delay, that's fine, Baba, no problem. So how much is the size? 6 bits, in fact. Actually, people, ports are also registered. Okay, size of the port register, or totally maximum size of the ports or any register is depending upon the size of microcontroller. So do you know how much is the size of your microcontroller? Whatever microcontroller you are using right now, do you have any idea about what is the size of PIC16F877A microcontroller? Again, don't predict. Don't predict. It's a request. Do you have idea about it? I'm sorry. I by looking at the responses, I can say that no. Right? So usually, if you talk about the any microcontroller, remember this, people. Size of microcontroller is equal to size of its data bus. Whatever is the size of data bus of microcontroller, this microcontroller size is that much. Okay, now see the data bus. Okay, see this block diagram. So are you able to see the data bus here? Are you able to find out the data bus in this block diagram, everybody? Address bus, program bus is different, data bus is different. Are you able to find out the data bus, everybody? So in front of the data bus nearby, whatever number is mentioned, that will be the size. So what will be the correct answer? How much is the size of data bus? 8 bits. So how much is the size of your microcontroller in this case? It is 32, it is 16 bit? No. How much it is? 16 bit. And what is, see guys, I'm making you independent, or not I'm keeping you dependent on me. So the same things you applied for any other microcontroller, generic things we are talking. So here, how much size of your microcontroller? 8 bits, which is equal to size of data bus. Great. Clear? Everybody, still now, are you able to follow me? So maximum register size, maximum microcontroller register size is going to be 8 bits. Fine. So where you see 13 bits, Baba, let me go here. The 13 bit is the program counter they are mentioning. Data bus size, are you able to see? 8 is mentioned here. Let me highlight this. Be careful. Are you able to see 8 here? Benita? Fine. This is about the program counter. Clear? Now why Earth still you are on the 16 bits? It is a 8 bit, not a 16 bit. Fine. Chalo. Now let me come back to the ports again. What is the size of port A? 6 bits, right? What about the port B, port C and the port D? How much is the size of these ports? If you talk about the port B, even port C and port D, how much is the size? 8 bits, right? The size of the port B is nothing but the 8 bits. Size of the port C is nothing but the 8 bits. Okay, and even port D is also having the size 8 bits. Okay, great, nice. What about the port E? How many pins are you able to see for the port E? Just 3 pins. How much is the size? 3 bits. Okay, fine. Any confusion still now? It's very important. I'm creating the BSA. It's very important. So how much is the size? 3 bits. Okay, great. Fine. Now, people, even if you see the block diagram, are you able to see? Let me take the example of port A. So, in front of few pins, multiple names are given. Are you able to see here? Let's see this example. RA3. Then again, in front of RA3, AN3 is mentioned. V reference plus is mentioned. Okay. Question is why the single pin having the multiple names. So if you ask me the port A pin names, those are RA0, RA1, RA2, RA3, RA4, RA5. But what about the other naming? So they are saying that since microcontroller is having the limited number of pins, so single pin can be connected to the multiple single pin can be doing the multiple functionalities. Yes, so for example, this RE3 pin is connected to the ADC channel 3, or even it is connected to the V reference plus. That's why you can see the multiple names here. Don't get confused. So just multiple names because it is doing multifunctionality. Same followed for the rest of the pins also, right? So it has a total 40 pins, Baba. Apart from the port pin, it is having other pins also, right? Okay, let me show you here. Just a second, pin diagram. Yeah, here are the 40 pins of the PIC16F877A. Okay, Nandini. Other than the port pins, it has a reference voltage, VDD, VSS, ground. Rest of the pins are also there, right? Yes, correct, Shivam. Don't worry about that. So understood whatever I was talking about the block diagram. So whatever things we noted here, are you clear with it? So just see, at a time we can't read all the things from the data sheet. Whatever information we wanted, we collected. We wanted the information about the ports of the microcontroller. So we got that information. Yes, no? We got that information. Yes, we got it. Fine. Okay. So on this note, let's stop this session. So rest are the things remaining part I wanted to complete in continuous session, continuous at least 1.5 hours, so that you will be understanding the topic clearly. So whatever remaining part is there, we will cover in the tomorrow session. So it's a request to everybody, don't miss the tomorrow's class unless and until there is a emergency or you have a very other important work. Fine, be there in the tomorrow session, join the class on time. So that's it from my side. So if you have any queries, let me know. So first thing regarding your test score, I already informed to open the test score and it will be visible. Fine. No, Prince, not counted as a two. Means the same pin is connected to the, it is one pin only. It is connected to the two different peripherals. Means even it is connected to the, like for example, let me go back here. Just a second. Let me use the simple word, Nitin. Okay, if you see here, let me take the example of the some other pin also. Which pin I can take? Okay. Let's take this pin, simple. Okay, RA0. So what happened? This RA0 is the pin, only first pin of the port A, and that pin is connected to the analog channel 0 of the ADC. That's why in front of that name is given AN0, but it is single pin doing the multiple functionality. That's it. Understanding? I'm sorry. Non-OS means what? Non-OS means there will not be any operating system. Operating system is what you are having, the operating system like a Windows, like a Linux. So to develop the embedded system, it's not necessary to use always the operating system. So usually when you are working on the complex task is complex, then you may need a operating system to work on that task, OS. But here since we are developing the simple application like microwave oven, so we can do that application. We can develop this simple embedded system without using OS. That will be non OS based, or you can say that we are doing the bare metal programming without using the OS. So it's not necessary to have an operating system running in the embedded system. Understanding? Okay. So compiler, if you ask me, compiler is used. Abdul, I will answer this query, all these things in next session. So don't worry, people. So if you see, uh, okay, Prince, I hope you're clear. Shallow, then good. Okay, others, if you don't have any query, you can leave this session. No problem. Yeah, see here. So right now, in front of you, you will be able to see this board. So don't confuse here. That's fine. Many of you have worried about that. You install the Pixim Lab, but ma'am is having different board. I'm having a different board. So how to load the required board? I will guide you. Don't worry. Fine. As we are going to run our next program in the next class, so that time how to load these things we will see. Okay. Fine. Test score, as I said, it will be displayed soon. Don't worry. Programming, we started with the programming Prakul. To do the programming, we need a basic understanding. At least we wanted to know where the ports are there. So in tomorrow's session, we will see where the LEDs are connected, to which port LED is connected. Fine. I'm so sorry. Okay, see here. Does your microcontroller have only port pins? Yeah, thank you everybody for your teacher's day wish. Thank you so much. See here, if you see the pin diagram, in the pin diagram of microcontroller, here is the actual pin diagram. So how many pins you are able to see? 40. Apart from the port pins, you can see this VDD, VSS, rest of the pins are also there, no? So don't worry about that. Just go through this pin diagram and check all the pins. Okay, fine. Okay, still if you have any query, please let me know in the discussion forum. We will resolve there. Fine, fine. Don't worry about the EDC. I was just giving the example. Yeah, thank you everybody for your wishes. Thank you so much. So let's stop here. If you have any query, please post it in the discussion forum, and let's stop here. Thank you everyone once again.